Thank you everyone for joining. Really excited to have Gavin and Paul here to talk about versioning with data and especially how that is applicable to data mesh. So they've got a presentation here that they're gonna go through, and then we'll have Q&A after as well. If you do have questions, please throw it in the Q&A so that way it's in a centralized place and it's easier for the participants to find and do that. And if you've got questions that are kind of tangential around this topic as well, that is totally okay. But versioning is in general around data products is a very important concept. So wanted to have these two on to help us kind of understand what versioning really means and how it's applicable to data mesh. So with that, I'll shut up until we get to kind of the Q&A piece and let the two stars of the show take it over.
Great, thank you.
Thanks, Scott. Super excited to be here. I think I speak for both myself and Gavin. We definitely have a lot more time than content, so encourage your questions as well throughout the presentation and after. We're here to discuss what we've titled the cost of choosing to not version your data by Gavin, who's the CTO at Terminus DB. And myself, I'm a developer advocate at the LakeFS project, which we'll dive into a bit more of those two as well. So
I'll just go ahead and introduce myself, I guess. So I'm Dr. Gavin Mendel-Gleason, and I'm the inventor of the web object query language and the primary architect of Terminus DB. Terminus DB actually comes from a European project at Trinity College Dublin, and we spun out as a startup some 3 years ago. And we were really looking at the Seshak Global Historical Data Bank. So we were trying to do basically a data product that was designed for historical researchers looking at historical data sets to understand more about how societies are resilient, how to find out what makes societies resilient, and to understand better in a quantitative way some factors about past societies. And so that's sort of the genesis of this. And because of the particular problem, we ended up having a versioned graph database. And so we'll talk more about that later and why that helps.
That's awesome. Hi, I'm Paul. I'm again developer advocate at LakeFS. Before that, I was leading the platform engineering team at Equinox Fitness in New York. I'm very integrated into the data space and like contextualizing all the different trends and technologies and interacting with the community around it. So again, super excited to be here and do that today. Our agenda today, all things data versioning, what it is, how we define it, the benefits you get from it, relevant technologies to this feature, and lastly, some performance considerations or just considerations in general you should keep in mind when you're thinking about versioning your data. And of course, there will be the Q&A at the end. So let's dive into it. We're going to start with how does versioning apply to the world of data? I don't know about you, but when I think of the word versioning, the first thing in a technology context, the first thing I think of is Git, which was pretty revolutionary from a code perspective when it came to managing versions of files, particularly when there's many contributors working on a project. Git is not explicitly a versioning tool, in that you don't click a button anywhere that says save a version of my code here, but when you make a commit, an operation, it exposes what you're essentially doing is saving a version of your code. Git is so ingrained into development workflows that it's pretty hard to imagine what the process would look like at this point without it or something very similar. or maybe you can imagine what the situation would end up looking like, which is having multiple copies of either source code files in application development or data files in the world of data with hard-coded suffixes like V1, V2, final, and people's initials. Now, in terms of versioning, it doesn't have to live at sort of these two extremes. There's also, in the world of data, versioning, which can be thought of as like a transaction log, which is maintained by a database or similar system. But all three of these are examples of data versioning. So it's worth coming up with a more general definition that we can use. And the way I define it is the state of a data set at a given point in time that you can easily reference is a version of that data. And so while all of these are examples of versioning, even in a data perspective, I think we can agree that Git's use of branching, committing, merging, etc. operations is a much more scalable, seamless, and efficient way to handle versioning. So any versioning solution we think of from data should take more inspiration from the Git side of things than the hard-coded multiple copies of files. And frankly, if you do think to your own data sets, though, you might realize that you are living more in a world like the one on the left than the one on the right. So that's, to put it another way, there's a lot of benefits to having versioning of data in a Git-like way, and it's worth spelling what those are. They are very similar to what you get from a Git-like system for managing your source code development, but we'll go through them and say what they are from the data perspective. First and foremost, you have easier collaboration over your data through the ability to create isolated branches. Maybe you can create pull requests that people can review before merging data back into a main branch. And you can treat your data less like a shared folder, and you don't have to worry about a change you make potentially harming something else that someone else wants to do with the data. Next, you get faster recovery from issues. So instead of running, you introduce a new change or some new data enters production that breaks a dashboard or makes a machine learning model go all wonky. And the simplest way to recover from that is to revert, or have a revert-like operation to go back to a previous version of your data that did not have that issue. This is simpler than doing something like running a delete from query on your data warehouse, or going into your object storage, your data lake, and like individually deleting files after a certain timestamp. Another benefit is frictionless experimentation, where you can do things like test algorithm changes on feature branches and compare the results. Or another example would be testing version updates to a specific tool or technology and see what the impact is. And you can use this branch to make a copy of your data, like a separate version, run the change, and then when you're done, simply delete it. And this is all, there's no copying of files and leaving unnecessary files around in your warehouse or lake, and it makes the process more streamlined. And last but not least, you can even get to types of things like automated deployment workflows, where you have CI/CD of data, CI/CD deployment of data, where you have new data on a separate branch. You can set up specific tests that must pass before the data is added into main, which is pretty it's pretty important. It provides important guarantees around data that makes it into production when you compare it to the more common way of doing it now, which is you simply add data straight into production and maybe run tests after.
That's right. And I'd say that last one, the automated deployment, is the sort of most sophisticated, but I think it's the place that data really needs to be going. So continuous integration and continuous delivery was something that really was what made Git really revolutionize software development. Its capacity to run all sorts of tests on these experiments that you might have. So you'd have like a branch where you were doing a feature, you run a bunch of different things before it goes into deployment. So you know that the code is meeting a bunch of unit tests, some integration tests, and then subsequently it goes out into the actual deployment after these things happen. And right now with data development, this is all being done in a very ad hoc way, and it is much more like this user data final situation where you're trying to delicately change the database in such a way that it reflects what the state that you hope will make everything work finally. And we really have to be learning from the software development world about how to do data development in a more responsible manner.
Yeah, those are great points. I think it to put it another way, it offers the potential to change deployment of data, particularly when you're making a change from a very manual, labor-intensive process to one with more automation around it. Again, as you said, similar to what happens in application development, where there's a lot of emphasis on the staging, ensuring the staging environment is working, and then you very confidently make the change, deploy it to production, and it goes to users, and that's it. So what all of this might, the thought that might enter into your brain is, why not just upload our data files to something like GitHub and get this functionality? And the simple answer is that GitHub has a 100 megabyte size limit on files that you upload to it. So while that's actually big, like pretty large, and maybe larger than you would expect, it's not practical for most modern analytics use cases. And the data model that underpins Git just simply isn't designed to handle large objects. And so we get to this situation where there's a common belief about data versioning that it's impractical or too costly to maintain multiple versions of a data set. I have this large set of data. It's in the gigabyte or even petabyte or larger range, and it's very cumbersome to work with as it is, let alone when I start doing things like saving multiple versions of it to track changes and other things. And really five-ish years ago, I would agree with you, but the technology has continued to evolve, and a lot of smart people have identified this as a problem. And there's a lot of new technologies out there that offer versioning in some shape or form, which we'll discuss in a bit. This does bring us back to the title of this talk and what I call the truth about data versioning, which is that it's more costly to choose not to version your data. And I say this for two reasons, which we kind of already mentioned, but one, you miss out on all the benefits that we discussed before, related to better workflows around collaboration and resolving errors and going back and comparing versions of your data to identify changes in it. And this is due to the new technology that versions data in an efficient way that leverages metadata to not have every version be a separate copy of the data. Any thoughts there, Gavin? Or we can continue on.
Yeah, I mean that's the automation is really and not going to be possible without this. So that's I think a big plus.
Yeah. So this isn't to say that you cannot implement data versioning yourself. When I speak of all these technologies and tools out there, there's ways you can save snapshots of your data, which is something I've done to identify what's changed in the past hour or day in a specific table. But it's not simple to do it in a way as efficient as the tools that are now out there that you're probably not going to do it as efficiently. So it makes sense to leverage them. And
That's right. Yeah. So some good examples of that in actual transactional databases, it's very common to have some sort of version field and then the versions are updated, but then the versions are by a row. And how does that row connect to other versions of other rows and other tables? And then you have to have some sort of metadata structure that then it describes how the versions are being advanced together or in lockstep. And at that point, you're starting to build your own complete versioning product, and it makes sense to leverage technologies that already exist that do this at that point. It's also kind of tricky to get right.
Yeah. So there's a lot of tools that are now in the data versioning space. And they go about it in different ways, which we'll discuss. Some are more of the transaction log side of things, letting you jump around between different points in time and history. And there are tools that also go as far as providing this whole Git-like experience to provide versioning that also offer to change the entire workflow that you have around data as far as deployment and testing and stuff like that. So I didn't want to include detailed dives into how each product offers versioning. I can go into a bit of detail for the ones I have more experience with. Snowflake, for example. So whether you're working in a data warehouse, data lake, graph database, or in a machine learning, in an ML training platform, there are products that offer to help you version your data and get all the benefits related to that. Snowflake has time travel on tables and even on the schema level. By default, it is set to 1 day, and you can even set it to as far as 90 days in the past. So with this turned on, you can query essentially the transaction log of the table and materialize different states of your table at different points in time. Another example in the data warehouse category is DBT snapshots, which is meant to handle the problem of, I have a type 2 slowly changing dimension table. I want to know how the values within it have changed in the past hour or day. And you define a table as a snapshot table. And then once you run the snapshot command over a specific time cadence, usually daily or hourly in that case, you can run queries that select from the snapshotted table and do things like, for example, identify changed records. If you don't want to have to, if you don't want to have to, it would be hard to, you just want the changed records, not the entire table. What that lets you do. In the data lake space, you have Delta Lake, which gives ACID-like transactions to data lake. It gives ACID-like guarantees to data lake transactions. And it has its own transaction log, which you can jump around into by either using each mutation to the table will have a version number, or you can use the timestamp. It maintains this by default for 30 days, but you can actually extend it as long as you would like, I've found out, although there are performance considerations for that. particularly when running operations over the history. There's LakeFS, the project that I work on, which provides the entire Git-like operation set to data lakes and object storage. So you can do things like commit, merge, branch your data in a data lake setting. And this works across single tables or even in your entire data lake if you put it in a repository. We come up to the graph database side of things, which is Gavin's domain, so I'll let him.
That's right. Yeah. So Terminus DB is also, it allows you to do branching, and it essentially it just stores a delta encoding of each different operation that takes place, so that you can time travel quickly to any state of the database. And you can also you can cause a given commit to have a sort of materialized version quite quickly with what we call a delta rollup, which merges all of the deltas that take place in between. So it's faster than rerunning a transaction log or running a transaction log backwards. It also allows you to query for what changed in the particular time frame between any two commits, or at a particular commit, what the operations that took place at that commit were. And it stores metadata about the schema as well as the instance level changes.
Got it. Yeah, and similarly, I just wanted to mention LakeFS. It lets you similarly have commits of the data, and of course these aren't full copies of the data. They're metadata that essentially point to the files that is stored on the object storage itself. Lastly, in the machine learning space, those are the logos of DVC, DAGs Hub, and Pachyderm, which are tools. Experiment reproducibility is a big deal in that space. And so if you ran a training model over a specific data set and got a certain result, it's important to be able to reproduce that result. So when it changes, when someone runs it a month later, they know there wasn't an error in some way and can trust the results. So these are all platforms that are designed in some way to let you version your data sets and reproduce what previous states were, so you can go back to older versions of experiments. So those are tools that in some way allow for data versioning. When we think about versioning our data either in one of these tools, there's considerations to keep in mind that I think are useful to go over. And the first and foremost is, of course, why are you versioning your data? Do you want to traverse the history of how it's evolved and be able to materialize different states of it at different points in time? Do you want to be able to efficiently identify changes in the table over the past hour or day? In this case, you would want to save versions of that data set and that cadence, and then query between them to identify the changes. Or do you want to adopt more full CI/CD deployment workflows that we went over before to enable advanced collaboration over your data environment? So, what?
Sorry, jumping in here with a real quick question, which would be, can you talk a little bit about what are the problems that using this specifically might avoid, right? We talk about what is the use case, but like, if I'm talking about materializing the history, what is my problem set, especially, if you can relate it to data mesh, what is the problem set that's trying to avoid, right? Because I think data mesh is such a broad topic that helping people kind of talk about those very specific things can be really helpful as to what you've seen people go down the wrong path with, or what this is designed to avoid.
Yeah, I think that's a very good question. I mean, there's lots of different answers depending on which particular feature set you're looking at in terms of versioning. I mean, one of them is data lineage, right? So if something happens to the data is changed or altered in some way that causes it to become unusable for some reason. Say you're doing an experiment or something along those lines, you can see what it was that did that if you have information in the commits about who or which program was doing the commit and what precisely caused it to go wrong. That kind of information, that data lineage, gives you a sort of blame. And if you have automated processes that are doing automated updates in a database, then it of course makes sense to be able to pinpoint the location of that. If you're in a transactional database that's not keeping any versioning information, those sorts of things can be completely opaque. You just end up with a different modified database, and you don't know what caused the change, and you have no way to roll it back, and you have no way to ameliorate the problem. So that's a use case. You know, there's that is a problem that people encounter. I'd say another one of the problems that I think Paul already mentioned, though, is that just if you want to provide more automation, so you want to do some kind of screening of the data before you put it into production, it's a little bit hard if you don't have some sort of methodology that allows you to do this. And that's CI/CD methodology helps you avoid the kinds of problems that you encounter from putting into production data that hasn't been properly vetted. So that vetting step is useful, and that comes from having the ability to branch and the ability to rebase. If you can't branch and rebase, then it's a little bit tricky to have that sort of those sorts of CI/CD type characteristics.
Awesome, very helpful.
Yeah, so yeah, I'm going to add another point to that, which is in the data mesh paradigm, where you have, you own the publishing of your data, and I guess take on the responsibility of helping the different consumers of it. Different consumers might have different needs, and being able to manage different versions of data that you expose in this sort of way, without having, maybe you have more like hard-coded separate versions that an API queries otherwise. So the workflow around exposing different versions of a data set to different consumers, I think is powerful in a data mesh sort of setting.
Yeah, 100%. I would totally agree with Paul there. Like if you have some, for instance, personally identifying information in one of the data sets, and you know that certain individuals can see it, but you don't want to publish it to certain other departments or externally, then you can create a screened version, and that version can be part of your automated workflow, and you can make sure that it has the appropriate information in it. Alternatively, you could have versions of readers. The readers might expect certain data to be there, and so you have to keep backward compatibility in some way, and so then you can make a versioned data product that gives them a window where they can still use the product because of the way that they expect the shape of the product to be.
Mm-hmm. Great. Yeah, great question. Thanks, Scott, for raising that. So of course, another consideration is, yes, you will incur additional storage costs when you version your data, at least at the beginning. And it's sort of a question is, are those additional costs higher than the cost savings you're getting from having streamlined workflows around experimentation, around resolving bugs, around better collaboration, and all the benefits that we discussed in the beginning of the talk? Two important types of settings around data versioning that you should keep in mind are the retention windows and garbage collection settings. So retention windows are, I keep versions for X or retention windows. If you have data for, they're similar, but do I keep data that's older in versions older than X number of days? And if there's a branch, for example, in the Git sense that's deleted, when does data that is only in that version get removed? So these are two things to keep in mind that can help manage costs when you get into the world of versioning your data and not having your costs spiral out of control. As we've touched on, schema evolution is important to keep in mind as to how the usability of your version data will work. This depends on the technology and tool you're using. I know when I implemented versioning myself in sort of basic ways, I always made sure that if I was querying between versions of data that had different schema, it wouldn't throw an error or raise an exception when that occurred. It would handle that and I identify the new column as something that didn't exist in the previous exception, for example. Something like LakeFS, if you have multiple commits, it identifies. So this comes to like how you're identifying the differences between the data. LakeFS works on the object level, so it doesn't care what the schema of the specific data is. It's just whether the file itself exists in the two versions that you're comparing. Other tools, though, it is something you have to keep in mind with. I know in DBT snapshots, for example, if you change the data type in a table that you're snapshotting, you might come into issues when querying running a query over the snapshotted table. And in that case, you'll potentially lose your historical versions and kind of have to start from the beginning of saving them. And lastly, there's privacy and regulatory considerations to keep in mind. When we think of things like GDPR and the right to be forgotten, we're no longer responsible for just deleting someone's data from the latest version of the data set. We have to make sure that all versions of the data that they might appear in, we handle that. So it's a small complication and just something to be aware of with regards to that.
Yeah, you have to go back and revise history, which is a little bit awkward.
Yeah. So that's the end of the slides. We can have time now to open up for a Q&A. I see there are a few already in the chat we can address, or however we want to handle it.
Yeah, I've got a couple, and maybe I just wasn't quite grokking this, but like, you're talking about kind of what has happened. Is there a way as well to figure out what this is going to cause, right? When you think about like unit tests and integration tests and things like that, is there, when you're applying versioning, is there a way to tell the way that other people are consuming it? There is ad hoc consumption, but if there may be a way for those products to register how they're using their the data of the data product, is that something that's going to come, or is it something that has come, or things like that? Because I think when you think about the upstream downstream path with versioning of a data product, that could be something that's really interesting, but I also know that that's insanely more complicated. It's difficult to say, and it's easier said than done.
For sure. Can you restate that? You're talking about like identifying how consumers are consuming the data, or?
Well, so if you're talking about potentially changing your versioning as to the schema or things like that, right? That as this is changing, what impact is that going to have upstream, downstream? So say I'm doing my operational database and I'm going to be doing a schema change, and I know that that's going to happen ahead of time, is there a way to kind of test downstream as to, is that going to break at least the data products? Ad hoc consumption, you can't really say, but but then again, that person hasn't registered, kind of what their consumption pattern is. So you can't really ever change that. And they're just going to get what they're going to get when they go to the data product.
Yeah, no, that's a very good question. So, I mean, we're sort of working on some stuff around that at the moment. So the WACL query language actually can be saved in a Terminus DB as a structure, and you can have named parametric queries in there. And so what you can do is, for the data product, you can put some number of queries that are registered, and then those will allow you to see, if somebody's using those named queries, you can see when the schema is updated whether or not those will still work. So that gives you some kind of visibility, but we don't have a way of registering. Now there should be some sort of subscriber methodology, I think, that allows you to see what is being pulled in what way and how that data goes out, give you better visibility about what you need to continue to support, or what you're going to have to change in terms of downstream. That's a very interesting question.
Yeah, I think that empathy model within data mesh is something that's changing the way a lot of tooling works. So sorry, I don't want to monopolize the question. So if we want to jump into the ones that are in the Q&A, I want to offer that up for people as well. So why don't we just kind of, Paul, you choose one, then Gavin, you choose one, and you can both answer on it, but
great.
That way we can kind of round robin.
Sure. So there's one from Andrew. Git sees blobs, but it doesn't understand structured data as well. And this is a good question and a good point. So there's thinking of how to phrase this, but there's different granularities at which you will be able to identify differences between versions. It could be on an individual field level, a row level, or the object level. And there's implications for that, and you have to understand what's being saved in your versions. For LakeFS, it identifies differences in blobs or objects, and so it doesn't aim to solve what the specific change is. You have to then go in and run a query to identify that yourself. And if you do need to understand it on a very granular level, then you have to make sure you're doing that. What I can say is, in very large data sets, that this is giving a lot more efficiency to that process. And it's very useful many times to single out the changed objects first, and then go in to look for the more granular differences.
Yeah, do you have anything you wanted to add there? Or?
Yeah, I mean, like Terminus DB is sort of the opposite end of the spectrum almost in terms of that. I mean, the granularity, there's advantages and disadvantages to both. And Terminus DB is really on the structured data differences. You can see how the graph has been updated in terms of which edges and nodes were removed and which were replacing them in each delta. So that gives you quite a fine granularity. It's basically the, it's like row level, I guess you might say, except for the graph database version of that granularity. In terms of, there was a question from Mohammed Khorfa about what type of metadata should be carried out when versioning the data, and that's a really good question. So, I mean, I think that depends, and it depends on what kind of versioning you're doing. So Terminus stores information about commits, the changes, the deltas between graphs that have taken place, who did it, so the author of that commit, and then some kind of metadata. It includes a timestamp, and then it includes some sort of arbitrary message. but it may be that you need specific metadata about it, and it might be because of data lineage concerns that you have. And so there are other structured, I mean, there's other answers that might be there for specific use cases.
Paul, do you have anything you want to add there?
No, I was reading through the other questions, to be honest.
All right. So Paul, it's now on the round robin, so you go ahead and grab one.
Mm-hmm. All right. Mohammed also asked, is versioning metadata a good idea, or letting metadata derive it from the data? But I mean, versioning your metadata is, I think it's an interesting concept. You know, it seems like potentially you're getting down a rabbit hole of infinite versioning, essentially, that can
There's a good meme somebody posted around ML monitoring or ML model monitoring, and it was like, you know, the Spider-Man where it's like, you know, they're both like pointing at each other, and it was the same kind of concept of how far down that rabbit hole do you go. So, but yeah, I think there are some tooling that does kind of do that almost a CDC for your certain types of metadata. I think like Data Hub and things like that do that. But do you, sorry to have interrupted, but do you recommend that there's some level of that, or?
Yeah, I mean, let's go ahead.
No, go ahead.
Yeah, I mean, with certain kinds of metadata, it can make sense to version it. It just, I guess it depends on what the metadata is. I mean, there were some, if you're talking about like versioning the metadata from your versioning, that's probably overkill.
Yeah.
Yeah. So, you know, another thing to keep in mind is ultimately a human has to interact with the, well, not in some cases, like it's the human at the end that's interacting with this data. And if versioning it simplifies the way you can interact with your data, then that makes sense to me. But if it's something else to keep in mind when working with the data, I'm trying to think of a specific example, but
is it basically going to create more work for you because you're trying to generate this thing that nobody's ever going to use and things like that, versus is that what you're trying to say? Because or is it going to be incomprehensible stuff as well because there isn't a specific tool to help you manage that, you know, versioning of your metadata, and so then you're just signing yourself up for more work that's not necessarily going to be useful.
Yeah, well said. That
okay.
was my concern.
And I think it's very valid. So I think it's Gavin's turn to pick, right?
Yeah, I maybe briefly about the metadata question. You can imagine scenarios like when you are talking about some sort of regulatory situation. Perhaps you are keeping information about where you have all of your PII, and that kind of information about the personally identifying information, you might actually want to version that so you know when you knew something was PII, and so that when there's any kind of dispute about that, then you can say, okay, well, this is when we identified that existed, and we could only take you know, remedial measures after knowing about it. So that kind of thing. I mean, there is some sense potentially. I guess it would depend on a case by case basis what the metadata was. There's Andrew Padilla has a question here. Software developers rallied around Git as the source version control system. However, data stores are implemented to their uses and probably will continue to do so. Given that, how will the industry address multiple data stores with multiple ways to version? I mean, that's an excellent question. I think that the answer is kind of complicated. So Git chooses a fairly, you know, coarse granularity, and then they kind of give back information about diffs of lines between these granular commits that they have that have, you know, basically sort of hashes about them, so they know what has changed. So with data, you have a lot more complexity. So we kind of went the direction of graphs because graphs are very abstract, and so a lot of things could fit into a graph. So in some sense, you could fit other models inside of a graph model. The same is true for relational databases, though. You could also fit a graph into a relational database if you wanted to, in a sort of a triple column store. So I think the answer is that it won't be solved easily. It's not going to be solved the same way that Git solved it, and we will see, that there are going to be different version control systems for different types of data uses.
Yeah, no, I totally agree, and yeah, I mean, you're beholden to the technology you're using at some level, and you're not going to abstract everything away. And certain things are designed for certain use cases, and that's a good thing. Not everything's going to solve every problem. So, one thing that comes to mind is GitHub, or Git has the idea of a repository, which is sort of like a logical separation between, an individual project that you want to version. So, and people make use of multiple repositories all the time, especially in a microservices type of world. So, I know those are all, let's say, like the same thing, as opposed to having like different data stores. But you can, doesn't have to be like a mono repo type of situation with data. Obviously, that is assuming you're using like the same sort of object store. I'd also be remiss to add that LakeFS, for example, it's agnostic to which object storage you're using, that it provides these Git-like operations over. So it can be S3 or ADLS or other solutions like MinIO, that you get this ability to commit, merge, etc. over. So in that case, you can sort of use multiple data stores, not within one repository, but you do get the same operations over different data stores.
And then I'm not sure if Avi's question is kind of the same general topic of that, but I think that could be an interesting one of, you avoided the how to version data potentially because it's a difficult topic. Every data store may need a different tool. Can you elaborate on the tools that we have out there? What shall we look in a tool?
Yeah, I mean, so I tried to give a high level overview of the main ones out there and that we have experience with. I mean, I've implemented versioning myself in the way of taking a data warehouse table and like running, I forget the command now, but like export, saving it to an object storage every hour or every day in its own partition. And then you can query between those partitions to identify, changed records. And you can just think of each one as its own version of the data set. This is similar to what, again, like the type 2 slowly changing dimension tables, where you want to keep a historical record of how certain records have changed. And that's doable. It's just inefficient in the way that it saves an entire copy of the data set every time. And there are tools that leverage metadata to reduce the amount of data copying that goes on between each version of the data that you save. So, I went through examples of how it works in Snowflake and Databricks, and the way dbt helps you do that over your data warehouse. LakeFS and Terminus DB have versioning as a pretty fundamental concept, for example. So my point was more that regardless of what type of technology or what type of environment you're in, data lake, data warehouse, graph, database, there's a tool out there that supports versioning, and it's based on the use case that you have and the features, the way it's implemented that determine how much versioning, how much history you want to save, how frequently you want to version your data, and the way you want to use those versions that is just whatever your needs are, and sort of on a case-by-case basis.
Gavin, do you have anything you want to add there? Or?
Yeah, I think Paul covered it pretty well. I mean, I don't know what to say other than like what's the precise use case will probably dictate what the easiest tools are to use in that use case.
Okay, yeah. And then we've got 2 more questions in here, and then I think.
So for Mohammed's question on how do we track the transitive dependencies between version data? Well, here I think Terminus has a really good answer. Is we're a graph database, and so we do path queries very naturally. So we have a very natural language by which you can search through the commit history. So you can see what branches exist. You can say, oh, what commits are in this history. That kind of thing is quite natural in WACL.
Paul, do you have anything you wanted to add?
That makes sense. What transitive dependencies? I just want to make sure I understand. I guess that it's referring to schema, or just how a specific record has evolved between the versions. Is that the way you're viewing it, Gavin?
That's how I interpreted it to mean. So like if you have, you can imagine in Git, you have the railroad diagram of the branches as they, spread out, and then you have rebases and merges that bring them back together. Then that kind of is a graph, although it's a it's a DAG, I guess, because you don't get to go loops in time. But that's, yeah. So it's fairly, that's what I was interpreting it to mean.
Mm-hmm. Yeah, and similarly, just speaking from what my experience, LakeFS is similarly, built around this Git for data model, and the ability to compare between branches and view what the branches are in a very Git-like way in terms of the UI and the commands available to you. They're exposed, and I can just say it's a more elegant solution than not having that, where you go back to the hard-coded copies of your data set, which is kind of the other option for this. So
okay.
It's something to get used to a little bit, but once you get in those workflows, it's pretty natural.
And then Mohammed had another good one around how would you advertise the versioning removal when data products get retired in dependencies of dependencies. So this is kind of a big concept within data mesh as to parts of a data product getting retired, or the entire data product itself. And like how, again, we talked a little bit about advertising is not necessarily there as to ahead of time this is going to happen, but as well, like if somebody has a fail on their query or something like that, Gavin, you kind of mentioned the registered query. Is there a way with that versioning to explain what happened, or whether that's an automated message that is like a get blamed kind of thing where they can track to that from a code basis, or even just putting something in there as well? So,
yeah, I mean, I think that's a great question. And so we, in our roadmap, we have published pub/sub type architecture for Terminus DB. We don't have it right now, but we've realized that it's really important to have it precisely for this type of thing, so that you know who's subscribed to you, you know what they're trying to get. And then once you can see that, then you know when you're going to have to advertise that something is dying. You'll know who to at least, talk to, if not also have some kind of automated procedure for giving warnings. So we right now, it would have to be sort of a process. It wouldn't be a tooling situation, but we'd like it to be automated more. So we're looking at that at the moment.
Yeah, that's similar to my experience as well. I mean, one thing I think of is, especially in maybe the most common data mesh situation with like internal consumers within a company, is to exchange data on the API contract level as much as possible, as opposed to the data itself level. It just gives you more flexibility to, that it's your responsibility to make sure that even as you make changes to the data behind the scenes, you're still adhering to the data model contract specified in the contract with your consumers. And yeah, it's manual as far as retiring a version. We would do things like give, in our minds, ungodly amounts of time for people to upgrade their consumer process, like 6 months or even a year, and maintain old versions. But ultimately, it was manual as far as adding warning messages to the response or just talking to people.
And then we have one last one, which would be kind of the buy-in, right? Like what I think this is something that's big in pretty much all aspects of data mesh. It's just like we're telling people to do things differently. What actually gets them on that hook? What gets them convinced that they should be versioning their data? And specifically, Mohammed asked about data scientists, but you could kind of expand that further if you wanted.
So what resonates with me is thinking about what I end up spending time on that takes away from me being able to develop new things. And a lot of times those are fixing, looking into finding root cause and fixing errors of either production errors, or it's difficult or slow for me to test new changes and compare how the different versions compare. In simpler data environments, I'll admit it's not as pressing of a need in my experience. You can get away with creating multiple copies of the data more simply. But if you do get to a state where you have larger data sets and you want to move more quickly, then you come to a point where being able to version data efficiently is a really effective way to test new things, look into, reproduce the state of a data set at the point of an issue and understand the root cause. And of course, as your team grows, to maintain better collaboration workflows. These are all things that versioning enables, that if you find yourself spending too much time on the things that you don't want to do, or the processes are too thought intensive, then versioning offers a way to simplify all that.
Gavin, anything you wanted to add?
Yeah, I mean, in my own experience from working in machine learning, there were numerous steps to data cleaning that were necessary, and those steps I had different hand versions. I was versioning by hand, like with file names, etc., in order to set up the pipeline. Now you can use pipelining software, etc., but then like if one of the stages of the pipeline is wrong, then you need to have some way of starting over again. So you want to do it experimentally. So even the data cleaning phase is sort of experimental in my experience, where you're trying to figure out how to massage it into the right format. And I think data versioning for data scientists, is really a no-brainer there. It simplifies that procedure. It makes it more reproducible and easier to do in the end, and less trouble than trying to do it with a bunch of file versions in your folder that you're keeping track of.
Yeah. Okay. Well, any last kind of comments before we let folks head back on to the rest of their day? Okay, that's totally all right. So thanks again for Paul and Gavin for joining us for this very, very educational. We'll have the recording up relatively soon for folks. So, look for that on YouTube, and we'll drop in the LinkedIn profiles for everybody, so that way you can go and follow them there, connect with them there if they've got questions. And again, both LakeFS and Terminus DB are open source, so that was part of the reason why we're good with doing this rather than trying to do a tool talk or a vendor talk or anything like that. So we really appreciate all your time, and look forward to providing more information for all of you data meshers relatively soon. Thank you, everybody.
Thanks, Scott. Thank you very much for having us.
Thank you. This was a lot of fun. Thank you.